The energy change needed for a change in temperature of a substance depends on the mass and specific heat capacity of the substance. So specific heat capacity is the heat required to raise 1 kilogram of a substance by 1 degree. So the change in thermal energy is equal to the mass multiplied by the specific heat capacity multiplied by the change in temperature. In symbol form, that is delta E equals m times c times delta theta. This is one of the equations given in your formula sheet. Now delta simply means change in, so delta E means change in thermal energy, and delta theta means change in temperature. The energy is measured in joules, the mass is measured in kilograms, the change in temperature is measured in degrees Celsius, and then the specific heat capacity, which is equal to the energy divided by the mass times by the temperature, is simply joules per kilogram degrees Celsius. Let's have a look at an example using this equation. 18 kilojoules of heat is supplied to a 2 kilogram block of steel, initially at a temperature of 18 degrees Celsius. The specific heat capacity of steel is 450 joules per kilogram degrees Celsius. Calculate the final temperature of the block of steel after the heat has been supplied. So questions will often ask for a final temperature instead of a change in temperature. So for the first step, let's list out all the key information and check the units. The change in thermal energy is given to be 18 kilojoules. Now in our equation we use joules, so we need to convert this so it matches. So that is 18,000 joules. The specific heat capacity is then given to be 450 joules per kilogram degrees Celsius. And the mass is given as 2 kilograms, and we want to find out the change in temperature. For step 2, let's rearrange the specific heat capacity equation to make change in temperature the subject. We'll have to rearrange this algebraically instead of with a formula triangle, but we can do that simply by dividing both sides of the equation by mass and specific heat capacity. And that gives us change in temperature is equal to the change in energy divided by the mass multiplied by the heat capacity. Then for step 3, let's substitute the values into the equation to calculate the change in temperature. So the change in temperature becomes 18,000 divided by 2 multiplied by 450. And that gives us 20 degrees Celsius. In the final step, let's use the original temperature and the change in temperature to calculate the final temperature. So the final temperature is equal to the initial plus the change in temperature. And that is 18 degrees Celsius plus 20 degrees Celsius gives us 38 degrees Celsius as the final temperature of the block of steel.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!